When I was 10, I found a coin in my grandfather's drawer. It was completely old and worn. I flipped it in the air, and for one split second, something completely magical happened. It wasn't heads, it wasn't tails, it was both. Now, of course, when it landed, it chose a side. But in that spin, that coin lived in two worlds. That is the quantum. In our usual everyday lives, things are pretty straightforward. They're solid, predictable. You usually know what's going to happen next. Drop a glass and it breaks. Turn on a light and it glows. But in the tiny, hidden, and magical world of particles, there are no rules, no logic. Life is completely unpredictable. These tiny particles have the insane ability to bend and blur the rules. A particle can even be in two different places at the same time. It can exist as a wave in one reality, but as a dot in another. It can even change depending on whether you're watching it. That is what scientists call quantum superposition. Now, the last thing that is going to come to your mind when you think about quantum physics is an animal or cat, right? But Erwin Schrödinger, one of the early quantum experts, devised a thought experiment. Imagine a cat sealed in a box with a tiny quantum particle controlling whether it lives or dies. If the particle goes one way, then the cat lives. But if it goes the other, poison is released and the cat dies. Now, here's the strange part. Quantum physics says that until you open the box, the cat is both dead and alive at the exact same time. It's absurd. It's shocking, but it's exactly the point. The cat was never about the cat, it was about us. Because in the quantum world, things don't just snap into one outcome on their own, they do it when you try to measure it. The very act of checking, of setting up an experiment to find out, changes the story. Now, I'm going to try and explain this from a slightly more scientific perspective. Like I said, in the quantum world, particles don't settle on a single reality right away. Instead, they exist as a range of possibilities, described by something that scientists call a wave function. As long as we don't interfere, these possibilities coexist. A particle isn't strictly here or there, they're described by probabilities. But the moment we try to measure or observe it, that changes. To measure something at the quantum level, we have to interact with it. And that interaction forces the system to choose one outcome. Now, eventually, the wave function does collapse and it does settle on one reality. This is known as the observer effect. And it doesn't necessarily mean that the universe is conscious or intentionally trying to hide information from us. It just means that observation is never passive. Gaining knowledge requires disturbance. And at the quantum level, reality isn't fully separate from how we investigate it. What we see depends on how we look. And that challenges the idea that the universe exists in a fixed, observer independent way. Maybe life works the same way. Each of us holds countless futures inside us, suspended like particles in this haze of possibility. Who we might be, what we might do, where we might go. Before we choose, all of these futures coexist. The version of you that dares to try, and the version of you that's afraid. The one that succeeds, but the one that fails and grows. None of these are imaginary, they're all real, waiting. And it's until we act, until we speak up, take the risk, apply, try, fail, and begin that one of these futures becomes real. And at that moment, uncertainty collapses into identity. And it doesn't necessarily mean that the paths laid out to us previously have all disappeared. It just means that we had the courage to look. It's until we act that we know what those possibilities really could be. Now, back to the whole scientific part. The crazy thing is, scientists have actually held real quantum lab experiments. Electrons fired one at a time behave like waves, spread out in two different places. But the moment we check to see which slit those electrons went through, they snap back into being tiny little dots. Now, the reason this doesn't really work with people, animals, daily life objects is because superposition fades as things get bigger. The universe doesn't let us keep coins or cats in two states for long. Larger, heavier objects tend to interact constantly with light, heat, air molecules, vibration. Every little act measures them and collapses their superposition almost instantly. However, these tiny particles have the insane ability to stay isolated long enough from their environment to maintain the superposition. Now, why does looking decide a specific outcome? That's the part even physicists argue about. We all know what happens, we just don't fully agree on why. One idea is called the many worlds interpretation. Think of it like this: when a coin spins, it doesn't choose. Instead, the universe physically splits. In one universe, the coin lands heads, and in the other, it lands tails. Both outcomes do happen, just not in the same reality. It's like watching a Spider Man movie. Every single choice that we make creates a new timeline, but we only experience one branch of it. And according to this, the wave function never really collapses. Reality just keeps branching out endlessly, quietly, invisibly. Another idea is much less cinematic, but just as unsettling. Some scientists think that the universe at its core is probabilistic. There is no deeper reason to whatever's happening right now. Quantum events don't have hidden secrets or secret truths. They simply follow mathematical odds. When we observe a particle, one outcome does happen, not because it was destined to, but because it just randomly did. No alternate universes, no hidden scripts, just probability playing out again and again and again. Then there's a third idea, one that scientists are actually still hunting for. What if quantum randomness isn't truly random? What if there are hidden secrets buried deeper than we can currently measure, quietly deciding on outcomes behind the scenes as we speak? Maybe a particle always knows what it's going to do. We just don't have the tools to see those instructions yet. It's like watching a magic trick without knowing how it's done. The trick feels impossible until the method is revealed. We all live with an unknown variable, the part of us that hasn't been tested yet, the outcome that hasn't been measured. But just like in quantum physics, it doesn't resolve until we act, until we take that one step that turns potential into reality. The coin is always going to land. The box one day eventually will open, but it's in the closed lid, in the spin, that lies something extraordinary: possibility. Maybe the question isn't whether we can solve for why. Maybe it's whether we're brave enough to find out what why is. Whether we're brave enough to wait for the coin to land, to open the box, to look, to choose, and in doing so, making why real. I'm Ahana Anand from DIAB, and thank you very much.